Today, we're going to explore the albedo effect, a crucial concept in understanding climate change. Albedo refers to how much of the sun's energy is reflected back into space by the Earth's surface. Changes in albedo play a key role in amplifying global warming, creating a positive feedback loop that makes climate change increasingly difficult to slow or reverse once it begins. Light-coloured surfaces, such as ice, snow, and clouds, have a high albedo and reflect a large percentage of the solar energy, whereas dark surfaces, such as oceans, forests, and bare land, have a low albedo and absorb more heat. For example, fresh snow can reflect up to 80 to 90% of incoming sunlight, whereas oceans may reflect less than 10%, absorbing most of the sun's energy. Albedo varies significantly depending on climate and location. Polar regions, such as Antarctica and the Arctic, have very high albedo due to extensive ice and snow cover. In contrast, tropical regions, dominated by oceans and rainforests, have low albedo and absorb more solar radiation. Seasonal changes can also affect the albedo. During winter, snow cover increases albedo in mid-latitude regions, reflecting more sunlight. In summer, melting snow lowers albedo, increasing surface temperatures. These variations influence both the local and global climate patterns. The albedo effect becomes increasingly important when linked to climate feedback loops. As global temperatures rise, snow and ice begin to melt. This reduces the Earth's overall albedo, exposing darker land or ocean surfaces beneath. These darker surfaces absorb more solar radiation, leading to further warming. This additional warming causes even more ice to melt, further reducing the albedo. This is known as a positive feedback loop, because the initial change, the warming, leads to the effects that amplify the change. The Arctic region provides a clear example of the albedo feedback in action. Arctic sea ice has declined rapidly over recent decades. As ice cover shrinks, darker ocean water absorbs more heat, accelerating regional warming. This phenomenon, known as Arctic amplification, causes the Arctic to warm more than twice as fast as the global average. Similarly, the melting glaciers in Greenland contribute to lower albedos, increasing heat absorption and accelerating ice loss, which in turn contributes to sea level rise. Once the albedo effect loop begins, it becomes reinforcing. Even if greenhouse gas emissions are reduced, the loss of reflective ice means the Earth continues to absorb more heat. This makes climate change harder to slow and highlights the importance of early action. The albedo feedback also interacts with other climate feedbacks, such as increased water vapor in the atmosphere, further amplifying global warming. The albedo effect shows how Earth's climate system is interconnected and sensitive to change. As ice melts and albedo decreases, warming accelerates through powerful feedback loops. Understanding this process helps explain why climate change can intensify rapidly and why preventing further warming is far easier than trying to reverse it.